Alrighty, so for this video, I will be going over exam questions. And these are questions that I put in my worksheet for my students. And I just want to go over these types of questions that we would get in an examination. Now, the first one, because I'm going to be doing two of them in this video. So this is the first one that we have over here. So we want to determine the value of A right now. So how do we do this? And I'll show you. If we do the following, right, we can see that here we have the following angles. So we need to look at the information that we have. So as you can see, we have an entire reflex angle over here. Remember, reflex angle is an angle between 180 degrees and 270 degrees. So that is our reflex angle. Now, let us see what else we have, right? We have a 34 degrees. And we also have B, but we don't know what B is. But guess what? We also have something sneaky over here. We have a 90-degree angle there. I just circled it. Now, if we were to just consider this 90-degree angle, which is the angle H, there's no specific letter over there, but that 90-degree angle that I just circled is going to fall a part of both, is going to basically just be the sum of these two angles over here. So that's what we're going to count it as, the entire angle. So let's do the following. How are we going to find A? Now, as you can see, every single angle, because it's not just a straight line in this case, we can clearly see that there is some type of revolution happening here. So if we add up all of these angles together, we should get 360 degrees. So how do we write this down? We do the following. We say that A, which we want to find, plus 198 degrees, which you are given, plus 90 degrees. Remember the 90 degrees that I was talking about? And now we just say that all of that is going to be equal to 360 degrees. Okay, because clearly we can see if we look at all the angles, I'm just going to quickly get rid of this red over here. We can see that at some point, let's look at it, let's say it starts from here, right? Then it's going to go make an angle here, then it makes an angle through here, then it makes an angle through here, and as you can see, obviously, it makes an angle all the way back. So that is our revolution. So in this case, we are just going to do the following. We're going to say A is equal to, and we're going to take all of the numbers on the left-hand side to the other side and change their sign from positive to negative. So we're going to type on the calculator 360 degrees minus 198 degrees minus 90 degrees. And we're going to get the answer of 72 degrees. So that is what we have, 72 degrees. Now, what is our reason? I'm just going to write the reason underneath, but you need to write your reason over here on the right-hand side of your first line or second line. But I recommend first line because that is where you start. So what is our reason going to be? Our reason goes as follows. Remember when we work, because the reason that we actually have the statement which is true, we worked in all the angles in a revolution. So that is basically our reason. Angles in a rev. Now note how I'm just saying rev as short. And I'll just say here equal to 360. You don't have to say equal to 360, but this actually gives us an idea over here. So all the angles in a revolution equal to 360 degrees. That is our reason. Okay, that was easy. Then we can just go to 3.2. So number 3.2 says that we need to calculate or determine the value B. So in order to determine the value B, let's just look at this over here. Let's look at our diagram again. Where is B? We can clearly see that B is right over here. But what do we notice about this entire angle over here? We can clearly see that there's a right angle, right? And this right angle is just equal to the sum of these two angles over here, which is B and 34 degrees. So therefore, 34 degrees and B has to, if you add them together, they have to give you 90 degrees. Because that is what the angle is saying over there. So if we say the following over here, we say that B plus 34 degrees is going to be equal to 90 degrees. Remember, we're saying that the sum of those two angles is going to give us the 90 degrees that we already given. and then we can take that 34 degrees over, and we'll get 90 degrees minus 34 degrees, which is going to give us an answer of 56 degrees. Okay, lovely. Okay, and our reason is going to be, okay, let me try and see if I can explain here. So we have two different reasons. Our two reasons are the following, and I'm going to see if I can actually just write this one down here. I'm going to give it a little bit of time here. We have the first one, which is going to be complementary. Complementary angles. And this complementary angles over here, and we have another one called supplementary angles. I did not type that correctly. Supplementary angles. Okay, now what is the difference between these two? Complementary angles are all the angles that are equal to 90 degrees. And the supplementary angles are going to be all the angles that are equal to, or not yet, 180 degrees. It's a reason that we need to know, because if we don't know this, then I mean, like, we can't like prove what we have done. I know it's obvious, it's from the diagram, but because we are adding two angles in a 90 degrees angle over here, as you can see from this step over here, therefore we will actually use this one over here. Complementary angles are equal to 90 degrees. So you can write that down as your reason, and I'm just going to leave it like that. That is the reason we use. Okay, let's move on to the next question. So here's our next question. This is a very nice question. It's not too difficult, but once again, this is straight lines. We're working with straight lines. I know you can see a triangle, but at the same time, it's not really necessary to just know your triangles. I'm pretty sure you can do everything without the use of the triangle properties. But let's go into this right now. Let us read the question. The question asks us to write down this. Okay, let's actually read the information we have. So given that QWR is going to be parallel to SZAT, and WX and WY intersect at ST ST at Z and A respectively. I am having a stroke here. Let me read that one again. WX and WY intersect ST at Z. There we go. And A respectively. The angle W1 is equal to 65 degrees and angle A2 is equal to 121 degrees. Use correct statements and reasons too, and now we're going to be writing down the sizes of A1, W3, Z2, and Z3, all of those angles. Okay, where do we start? The first thing, we need to consider our information over here. Where is QWR? QWR is this line right over here. This straight line right over here. And SZAT is this straight line over here. And they say that those two are parallel to each other. So we can see over here that this over here is parallel to this over here. Okay, what's our next thing? WX and WY intersect at ST. So basically, they intersect at ST, as you can see over here. This line over here, they intersect through ST, both of them. And at Z and A. So obviously they're talking about the intersection points are Z and A, respectively. Okay, let me not draw those because it's going to look confusing. Okay, and then they give us the sizes of W1, which is 65 degrees, which is right over here. And then they give us the size of A2, angle A2, which is 121 degrees. Okay, now let's answer these questions. Now, what do we need to do in order to find A1? So let's look at this. A1, if we want to find A1, let's first look, where is A1 on the diagram? So A1 is over here. As you can see, I'm actually going to do it in a different color here. I'm going to do it in blue, the workout. So as you can see, we have A1 right over here. So how do we find A1? You can clearly see that A1 and A2 are both on a straight line. So therefore, we can actually use the reason angles on a straight line. So we're going to say 180 degrees minus 121 degrees. And then the reason that we have over here is going to be angles on straight line. Okay. And then we're obviously going to solve for A1 over here. So angle A1 is therefore going to be equal to 180 degrees minus 121 degrees is going to give us 59 degrees. So we have 59 degrees right over here. Okay. So now we actually found A1. So now what we can do is find W3. Now where is W3? Let's look for W3. W3 is located here on the diagram. Now how can we find that? Okay, so we can kind of see that there is actually a relationship. If we were to look at the parallel lines that we have and compare them with the relationship between A1 and W3, we can see that there is actually a Z shape or an N shape in this case, right? Over there. And this angle is actually alternate to this angle over here because of the parallel lines. So we can actually say that there W3 is actually equal to A1, which is 59 degrees. So W3, angle W3 is going to be equal to A1, angle A1, which is equal to 59 degrees, as we know already. And the reason that we're going to be using is going to be the lines that are parallel, which they give us, which is QWR. But first we need to actually state which reason we used. And remember, we used the angles that were alternative to each other. So we can say that alt angles are equal. And then because, and which lines are parallel? It's going to be QWR is going to be parallel to SZAT. So it's SZAT. Note how the lines, remember I said that sides would normally be represented as two letters, but now I'm actually introducing you to the part where it's actually not just two letters. A side is just represented on the points that are on that side. So what are the points that actually make that straight line? And that is how we actually name the lines. Obviously, I didn't want to overwhelm you at first because there was a lot to take in at that moment. So now we actually know that lines can also be represented with 3 or 4 letters as well, depending on our situation. Okay, so we found W3. Now our next one we need to find is going to be Z2. Where is Z2 located on the diagram? We can see that Z2 over here is there. Okay. Now, let's look at Z2 in relation to something else on the diagram. Okay. Now, if we were actually observant on what's going on, and we can clearly see that it is lying in between the parallel lines, right? We can see that this 65 degrees is going to be co-interior to these because, as you can see, the parallel line over here, and then we have this type of shape over here. If you can remember that co-interior shape, which gives us that reason co-interior. So therefore, and what do you remember about co-interior angles? Both of the sum of the two co-interior angles will be equal to 180 degrees. So we can say this. That went way too far. So it's going to be Z2 plus 65. So let's do this. Angle Z2 plus 65. But I'm actually just going to take it over immediately. So Z2 is actually just going to be equal to 180 degrees minus 65. And then if you just minus, if you use that, put that in your calculator, or if you calculate it in your head, then you'll get an answer of 180 degrees minus 65 degrees, which is going to be equal to 115 degrees. I know I'm using a calculator, which I don't normally like doing, but at the same time, if I do make a silly mistake, then obviously the comments are going to go crazy on me. And plus, I'm making the video. I'm in the moment over here. I'm under pressure. Okay. So I'm bound to make a mistake at some point. Otherwise, yeah, I'm doing it for your guys' sake. So what reason did we use? We used the co-interior angles. So co-interior angles, co-int, that looks like coin. Let me do this. So it's co-int angles equal 180 degrees. And then because, and then we obviously have this exact same reason over here. So I'm just going to copy and paste it. So it's this one here, and then we're going to copy and paste. Great stuff. Cool. So there's our reason for the Z2. And we actually just found Z2 already. So it's nothing difficult. Now Z3 is the last one we are looking for. Where is Z3? We can clearly see that Z3 is over here, and there's no difficulty with this one. We can clearly see that Z3 and Z2 is on a straight line, so we can use angles on a straight line. Both of those angles added together will give us 180 degrees. So we can say over here that Z3 is going to be, angle Z3 is equal to 180 degrees minus, what was Z2? It is just going to be 115 degrees because we actually solved for it. And the reason over here is going to be angles on a straight line. Therefore, Z3 is going to be equal to 180 degrees minus 115 is going to be equal to 65 degrees. Now, I just realized there is actually another way you could have done it, but I'm not going to do it as well. The other way you could have done it, right? As you can see, let me get rid of all of this now. There's a lot of drawings over here. So as you can see, right, this shape over here, we can see that there's a line here, then it goes down here, and then there's like an F laying down or something. But we can see, because of the parallel lines, this angle is equal to this corresponding angle. So W1 is actually also equal to Z3. So you could have said corresponding angles are equal because QWR is parallel to SZAT, where we'll say W1 is equal to Z3, which is equal to 65 degrees. That is another way we could have done it.